So this was already in your notes yesterday. I'm just picking up where we left off. So we went through that one example where there was no context at all. Today I'm going to give you a problem that has some context, so you get a sense of what you're supposed to do when you have an actual word problem involving a binomial experiment. Okay? And here it is. Let's go ahead and get that in your notes, and then we will discuss what you need to do. Before we solve this problem, so we have to determine if this is a binomial experiment before we can use our formula. Okay? So, first thing we've got to figure out is, are there only two possible outcomes? And what are they?
Yes, no.
If they've gone or if they haven't.
If they've gone to the doctor or they haven't. So there's two possible outcomes there. Okay. Okay. Are there a fixed number of trials?
Yep, 10.
There are 10 people selected. Is what happens with the first person, does that impact what happens to the second person?
Nope.
Okay. So they are independent, and what is the probability that somebody will see a doctor? 1/5. 1 out of 5. Okay? So when we go through these problems, after we establish that it is a binomial experiment, what I like to do is set ourselves up like this. Because we need n, we need x, we need the probability of success and the probability of failure. And then once we have all of those things, then it's a matter of just plugging it into the formula. So, how many trials do we have? 10. How many successes are we going to have? 3. Exactly 3. What is the probability of success?
1/5.
So what is the probability of failure then? 4/5. Okay?
Well, P could also be 4/20 too.
Alright. Any questions about where we get those numbers from? So then it's just a matter of plugging them into the formula, simplifying. Okay, again, 10 choose 3. Probability of success and the number of successes, probability of failure, and actually the number of failures. Okay, so go ahead and do that calculation. That'll tell us the probability of 3 having gone to the doctor. Go ahead and do that calculation. I went ahead and just inputted all of this into the calculator as is, which you can do. Okay, when we get to a test, make sure you show the work, how you have it set up. That's going to be really important.
When you say when you had something, you just want us to write that out?
Yeah, so this is the work that you need to show. Okay, you can plug this into your calculator from here. Okay, but I want to see that. You've gotten, the probability is 0.20. How many have that?
I did.
Okay, good. So that's what you're going to do when you have a binomial experiment and how you're going to find the probability. Okay. The other thing that we need to look at for a binomial experiment is there's a different way to calculate the mean, the variance, and the standard deviation. It's actually, there's nothing different about standard deviation. It's still the square root of the variance, but there's a different way to find the mean and the variance. So that's the next part of this lesson that we need to talk about. The way that we find mean and variance for a binomial experiment, a binomial distribution, is a lot easier than what we just did. Here we go. First off, these are the 3 formulas. Okay? Now, again, the standard deviation is just a square root of variance, so nothing really new going on here. Here are the 2 new things. For a binomial distribution, the mean is n times p.
Oh my god.
So the number of trials times the probability of success. The variance is the number of trials times the probability of success times the probability of failure. And the standard deviation is just the square root of that. Example. Okay. A die is rolled 360 times. Find the mean, variance, standard deviation of the number of 4s that will be rolled. Okay? So, couple things. We have a fixed number of trials. A success is rolling a 4. A failure is not rolling a 4. Each time the die is rolled, the probability is not impacted on the next roll. So it is a probability experiment. So all I need here in order to find the mean, variance, and standard deviation is N, P, and Q. So why don't you go ahead and identify N, P, and Q first. Then you can go ahead and find the mean, the variance, and the standard deviation. And let's see what you should round to. Let's go the 100th place again when necessary. Alright, so let's just make sure we're set up right. So take a look up there. So there's N is the number of trials, 360. Probability of success, getting a 4, 1 out of 6. And the probability of failure, not a 4, is 5 out of 6. How many had that part set up right? Okay.
Everyone.
So go ahead and just find the mean, variance, and standard deviation. So here's the next place I go with this. Just my what I'm looking for. So I get the mean, variance, and the standard deviation. Then I just have to do all the calculations. Again, write down what it is you're doing to come up with these. So for the mean, we just have to take 360 times 1/6. That is 60. How many had that correct?
I know.
Okay. So then the variance, you just take what you had for the mean basically and multiply it by the probability of failure. So that would have given you 50. So then for the standard deviation, square root of 50, which is 7.07. How many had all three of those correct?
Well, I had 5 radical 2, but it's the same.
He literally just said you were trying to simplify radical.
Yes. So, yeah, I don't want to simplify radical. This is statistics. I want decimals.
Okay, I apologize.
Okay.
Very sorry.
All right. So yeah, when we're looking for statistical data, those are in decimals. Okay. Any questions?
No, sir.